Hello everyone. Today we are going to learn one more most important algorithm, that is 01 knapsack problem. Imagine you are a thief with a bag that can carry only a limited weight. There are several items available and each item has a weight and a profit. Your goal is to select items in such a way that the total profit is maximized without exceeding the bag's capacity. So the interesting part is that for every item you have only two choices: either take the item completely or don't take it at all. We will be having another similar knapsack problem, that is fractional knapsack, which we will be taking a part of it even though we cannot take it fully because it exceeds the bag capacity. But here we will be taking either completely, that is completely take is 1, don't take is 0. So hence it is called as 01 knapsack problem. Here we will be having 4 inputs. So the inputs are, we have to give the weights available and the profits which is respectively for these weights. So the number of objects, if it is 4, then we'll be having 4 weights and 4 profits, where each corresponding weights are there for each profit. And the capacity of the knapsack, that is the bag where you can take from these weights, and the number of objects. So let us take an example and do it manually first, and then we'll look into the code and run the program. In this example, I am taking the weights as 1, 3, 4 and 5. The profits, I'll be taking it as 1, 4, 5 and 7. The capacity of the knapsack is 7 and n is equal to 4, that is the number of objects. So that refers to this 1, 2, 3, 4. For corresponding weights we have 1, 2, 3, 4 profits. We have to create a matrix that runs from 0 to 4, where there are objects or I or n, and from the capacity or the weights we'll be having this side till 7. So from 0 to 7 and 0 to 4. For our reference, let us write the P and W values here again: 1, 4, 5, 7 and 1, 3, 4 and 5. So in this problem, the knapsack is also a top to bottom approach. So top down approach, we will start filling it from top to bottom. So this row and this column will be filled with zeros because both the weights and the objects are 0. After this, we'll start filling. For weight 1, the profit is 1. Weight is here, weight is 1. Profit will be writing here. So whatever the values we are writing inside this box, inside the matrix, is what the profits. Whatever the profit we got in the down bottom right side is the final profit what we get. So all these values what we fill here is profits. So for the object, here you can also write the objects again 1, 2, 3 and 4. For the object 1 we wrote as 1, and we cannot add any previous object because this is the first object. We cannot add any previous object to this, so we'll leave it. For the second object we can add the first object. Before that let us write this. For weight 3 the profit is 4. In the object 2, by adding 3 plus 1 4 and 4 plus 1 5 we get, that is written here under weight 4 in with the same object but by adding the previous one. And we'll move to the next one. Object 3 weight 4 and profit 5. Object 3 weight 4 and the profit is 5. Now we can add 4 plus 3 7. Yes, it is within the capacity of the knapsack, so we can use that. That is 9. We can also add 4 plus 1, the third object and the first object, 5, which gives us 6. So we'll be writing it here and we'll move to the last object. So with the weight 5 we have the profit as 7. By adding 5 plus 4, that is the previous object, we get 9, which exceeds the capacity of the knapsack, so we cannot use that. By adding 5 to 3 we get 8, which is again more than the capacity of the knapsack. By adding 5 plus 1 6, we get 7 plus 1 8, so that we can write it here. So I'll be marking the values that we have just wrote by using the profits and the weights. Now we have to start filling the other empty values here in the graph. So how do we do that? So we have to check both the left value and the top value, which is greater, that we'll be writing it here. So in these two, of course, one is greater. Again these two, 1 1, and since the top values all are zeros, we have 1 in the second row. Again here we have to check this value and the top value. Now top value is greater, that is 1, and 1 both are equal. Here 5 and 1, so we'll write 5. Again 5 and 1 5, 5 and 1 5. Here 0 and 1, 1 and 1, 1 and 4, 4 is greater. 6 and 5, 6 is greater. So again 1 1 4 5, and among 8 and 9, 9 is greater. So see, as I told earlier, this final right side bottom box, what we get is the profit. So the profit for these profits and weights in this given capacity of the knapsack is 9. So now we'll look into the code and give the same input and check whether we get 9. Coming into the code part, I've already written the package and the import statement. Starting with the program, the class name should be same as the file name. I have given it as demo, and the main method, the return type of the main method is void, and we have to create an object of scanner class. The scanner class will be inside this utility class, so if not importing everything, that is this asterisk, you can also write scanner here. So from the utility class we are only importing scanner or everything. So I will be importing everything, and we have to give the prompts for the user to take the input. Since there are 4 inputs in this knapsack problem, enter number of objects, and we'll take the n as input, and we have to declare variable for weight of size n. We have to declare an array for profits of size n, and we'll take those array. Since this is a 1D array, we'll be using one for loop, and the same way you have to take it for profit also. We have taken three inputs now. The other one is capacity of the knapsack. That will take it as C, and all these to the knapsack method, that is weight, profit, N, and C. That will be defining it here. Profit, number of objects, and the capacity. In this, we need another 2D array, that is what what the matrix we wrote, 0 to 4 rows and 0 to 7 columns. For that, we need a 2D array called, we'll name it as K, which holds n plus 1 and C plus 1. There also we had taken it as n plus 1. Since our n was 4, we took it from 0 to 4, that is the number becomes 5. And on the top, we had written from 0 to 7, that is 7 was C, plus 1 is 0 to 7. We had 8 columns in that matrix. So this will define, and there runs a for loop. There runs two for loops with a if statement, that is, if the weight of the index I minus 1 is less than or equal to the W value in the for loop, then we have to give the k of I of W value as maximum of P of I minus 1 plus k of I minus 1 of since k is a 2D array, this is one bracket, and here is the other column index what we are giving, W minus weight of I minus 1. And this, after the comma, we are writing it as k of I minus 1 of W. So among this value and this value, we have to find the maximum value, and we have to keep it in k of I of W when this weight is less than the W value. If it is not less than that, then we have to give k of I of W value as k of I minus 1 of W. Only the second part what we wrote here. That same thing will be written here. After this, after all the for loops, we have to print the profit. That will be printing k of n of C. So for K, we had written N plus 1 and C plus 1. So that same N and C value, that is the last box what we got, the right side bottommost value will be given by NC. So that K of N of C value will be the last cell in the matrix, which is the maximum profit we get. So we'll run and give the same input. Enter number of objects. We had taken 4 objects. The weights were 1, 3, 5, 1, 3, 4, and 5. The profits were 1, 4, 5, and 7. The capacity was 7. The profit we got was 9. I hope this algorithm is clear for all of you. Thank you for watching, and for more such videos, please subscribe to my channel.